The topic of this video is equivalent resistance in series circuits. Here I have a series circuit with 3 resistors in it, all hooked up to a battery. And the goal of working with equivalent resistance is that you would turn something like this kind of circuit into one that looks like this, that's equivalent, because this is far easier to analyze. So it's easier to analyze. So how can we make the jump from something that's complex to one that is simple? Well, we need to think about first what a series circuit is. In this series circuit, we have a voltage from the battery, and each resistor will get part of the potential difference. What does that mean? We have some voltage here, and part of this voltage will go to this resistor. Part of the voltage will go to this resistor, and part of the voltage will go to that resistor. While the current I is the same for each resistor, the voltage will be different for each resistor. So I could say that the voltage from the battery is going to be V1 plus V2 plus V3. Or I could define this to be the voltage drop across this resistor would be the same as all 3 of these. So let's, let me put this in pink here. So this voltage drop V1, this voltage drop is V2, and this voltage drop is V3. And we're going to try and come up with an expression for the voltage drop over the equivalent resistance here. So let's use Ohm's law, why don't we? Remember that Ohm's law is V equals IR. So plugging this in for every term, I get I1 times R1 plus for V2, I2 times R2, and for 3, I3 plus R3. But we remember that I is the same for each resistor. So each one of these is just I don't have to label it in subscripts. All of this will be equal to our voltage here, which is R. I'll call this R equivalent because that is what we're after here. All of these are the same I, so I could, I made a mistake. This is not plus R3, this is multiplied by R3. Each of these has an I term that is the same because I1 equals I2 equals I3. So I could divide each term by I, and I'm left with this. Req is equal to R1 plus R2 plus R3. So if I want to turn this circuit into one that looks like this, I just have to add up all of the resistances so that I can get my equivalent resistance. So our equivalent resistance is R1 plus R2 plus R3 plus however many resistors you have in that given circuit. And if I were to put some numbers to this, let's say that I have a resistance or a circuit with 3 resistors, 3 ohms, 2 ohms, 1 ohm. If I wanted to turn it into this equivalent resistance, and this is a 9-volt battery, I just add them all up to get my Req, which would be 6 ohms. I still have my 9-volt battery, but now I could figure out the current running through this circuit, which is V over R, which is 9 over 6 amps. So that's how we could take a series circuit and turn it into an equivalent, simpler circuit. What about if we were given a parallel circuit? What about for a parallel circuit? We were trying to figure out equivalent resistance. So here we have, let's say, our battery, and we have a split. There's a resistor here and a resistor here. Then they meet back up, and then they meet back to the battery. Okay, this is R1, that's R2. Actually, I want to cut this. I'll talk about this in a different video.